This part we'll learn how to calculate process sigma. So let's continue with it. For calculating process sigma, we have to go through some of these equations. First one to start as the defects per unit. Okay, this will allow you to uh, calculate the number of defects in each unit. First formula here, DPU. But the important formula that would be actually used to calculate this process sigma is defects per million opportunities. This is the one that is used for finding the process sigma. Uh, but we can use some other formula like here yield and DPU to understand the various aspects of process sigma. So let's start with DPU. We already have discussed what it talks about. Here, one of these term is a little confusing for many. That is number of defects opportunities per unit. Now, what does it mean? It refers to a number of defects that can be out there of a unit of a product. Like here in this water bottle, uh, you can see there can be several defects, starting with here the nitrate level, then the pesticides, lead, chloroforms, and so on. And you can see there are seven defects that can be identified in this product. Okay, so uh, each of these defects actually representing an opportunity for defects to occur. So our responsibilities would be, of course, to minimize these defects as much as possible. So that's what it means by number of defect opportunities per unit. So in this case, our defects opportunities per unit would be about seven. So this is the formula that we use for calculating defects per million opportunities. Let's just go through an example and understand the whole process of calculating sigma of a process. Like this is the problem that we have in hand here. Teconico call center is committed to provide service to one of their valuable clients at least at 4 sigma level. So that's what they promise, that the clients will get at least service of 4 sigma level. The quality control team has been assigned to check whether the company has been meeting the standard set by its client. Blackwell leading the team found that each call has 3 defect opportunities. He monitored over 324 calls, and it was found that 13 calls did not meet the desired standards. Calculate the sigma of the company's process and determine whether they are meeting the target level. So let's try to solve this problem. We try to calculate the sigma level of the process here itself of this call center. So let's check. So now let's start calculating. Let's first start with defects per unit. First one, the problem with Teconico was the number of defects was 13. So let's just write down 13. And number of units that they had gone through was 324. Was number of defects per opportunities per unit was 3. Okay. If that is the case, the TPU would be about 0.01337. So this is the defect per unit. Okay, so this is how you calculate defects per unit. But for calculating process sigma, the most important part is here, the DPMO. I will see why this defects per unit is important. This would be important to calculate the yield of a process. So we'll come back to that particular topic in a few minutes. But let's just first calculate the difference per million opportunities. So this case you can see is the same formula that we applied this part, the first part here. You can see this particular part as same as this one, this particular part. The only difference is we are now multiplying it by million units. Okay, so that will give us the difference per million opportunities. So that is the case. Let's go through this again. Sorry, it's 13 to start, number of defects, and number of units that they had gone through is 324, 3 defects per opportunities, and we are trying to not only find the defects per opportunity but per million opportunities. Okay, so that is the case. Defect. If that is the case, let's check what is our DPMO here for 13,374. Okay, so this is my DPMO. But what does it tell? It tells in 1 million units what would be the total number of defects that are likely to occur, and that is 13,374. We know that to achieve a Six Sigma level, we can only afford to have 3.4 defects per million opportunities. So this is far away from that desired Six Sigma level, but we can still see whether it meets the customer demand. The customer demand is they are looking for Four Sigma level, as what we had noticed. So does it meet that demand? That's what we're going to check. So for that, we would require the sigma table. Okay, so this is the sigma table. And let's see where this TPMO belong at what sigma level. And we will be looking for a range of 13,000, and you can see here, about here, 13,900 uh, is the closest number of this one, and there is this one too. So the sigma level lies somewhere between 3.7. You can see the 3.7 or 3.8. So does it meet our customer demand? No, it doesn't, right? Okay, because customer demanded a sigma level of 4, where you can see this at sigma level of 4, you can only have 6,210 defects per million opportunities. And here the defects level is more than that amount. And so we fail to you know, meet the customer demand, or Technica fail to meet the customer demand. So this is how you basically calculate sigma level. I'll show you how to calculate in Excel in a few minutes too. But before that, we let's try to figure out this particular value too. Sorry, this DPU. Okay, so what is yield? Yield is nothing but 1 minus DPU, and DPU is defects per opportunity, and we already know this value. That is 0.01337. 0.1337. So what is our yield here? The yield is about 0.98663. Now what does it mean? Yield indicates the ability of the process to produce defect-free units. So the process has the ability of 98.663% of not producing any defect. So it tells you, and it gives you an important information here too. Now let me show you the process sigma calculation in Excel quickly. So same information here. So how do you calculate the DPU? Same thing. Okay, we will take the number of units divided by the total number of defects multiplied by opportunities per unit of defects to occur, and that will give us the defects per unit, the same result that we had found when we try to solve the problem manually. Now we're doing it in Excel. That's the only difference. Now, what is the yield? We can just calculate the yields directly here. It's one minus uh, it's one minus TPU, right? So this is the yield, and that's exactly the result we had gotten there too. And then what would be the DPMO? DPMO is nothing but this number multiplied by 1 million. So do it. And look at this. This is the DPMO. That's exactly the same result that we had seen when we try to solve the problem manually. So how do we calculate process sigma without using table in Excel? It's pretty simple. Let me show you. You can use this formula norm as inv, and then take the yield value and then multi and then add 1.5 sigma. This is shift. This is the adjustment that made with this normal curve formula that we know, the normal curve that we know in statistics. So this they take 1.5 sigma shift here into consideration, and that will give you the process sigma, and that is 3.71, and this is the actual sigma level that the process is working at the moment. So that's all we had for process sigma calculation. Hope you enjoyed it. Please make sure you answer the questions that have been asked, and I wish you the very best. Thank you.